Okay, I'm going to do one problem from the Module 4 class worksheet. For the binomial one, I'm going to do number 21 on the second page. It's talking about students passing a statistics exam. So from the problems, which is here, I copy it. From the problem, we know that we have the student passing rate for statistics class is 67%. We know this class size is 46, and we're going to using the binomial distribution. So we're going to figure out what is x is, what is p is, what's the probability, what is the n. I'm going to switch the positions, n and p. So x is stand for what are we looking for, and this is going to change from problem to problem. N is going to be the number of trials, or you can also treat it as the sample size. P is the probability of something can happen. So from the questions, the probability that a student will pass Professor Badlin's statistics class is 67% for a class of size 46. Use the binomial probability distribution, so we know the probability, the P, is going to be 67%. N is the number of trials. Since we're talking about a class size of 46, so the number of trial is 46. X is going to change from problem to problem. So I'm going to do A first. So A says half of the class will pass. Half of the class? This is more like an exact half of the class. It's not more than half of class, it's not less than half class, it's exactly 50% of the class. So half of class, that is 46 divided by 2, which is 23. So half of class is going to pass the exams. This is exact. So exact, when we're talking about binomials, we're going to use the probabilities. We got x exactly equal to 23, 50%. Is going to be, I think I erase it, p of x equals 23 equals, so the probability I'm going to using the binomial distribution. The first is number of trial, the number of s we're looking for. So for this case is our x, which is 23. Second number is the number of trials, which is the n, 46. Probability is our p, 67%, 0.67, and then it's cumulative or non-cumulative. So since we already talked about this is exact, so it's non-cumulative, 0 for false. So it's about 0.69, 0.7%. Just to show you one more time about the binomial functions. So for the binomials, the first is the x, the second is the n, P and either 0 or 1, which is true or false for the cumulative. So that's the first one. Then the second question is asking, for B, is asking what about at least 20? So from the questions we know it is going to be, copy, it is going to be cumulative. It is going to be cumulative. So at least 20 will pass. X is going to be 20. At least 20. That means we're looking for 20 and up. For the binomial functions, for the cumulative versions, you can only calculate the lower or just calculate the cumulation from the lower part. So for this one is the upper part, we cannot do it. We have to find the complement. So first, I'm going to find the probabilities of X less than, or the complement of the at least 20. So the complement of at least 20 is going to be less than. It's going to be less than 20, but we're talking about discrete, so it's actually going to be less than or equal to 19. So starting from 0 all the way to 19. This one we can do the cumulative binomials. So it's going to be equal to binomial distribution. 19 is going to be the X. 46 is still going to be the trial. 0.67, and we want it to be cumulative. So yes. But this is the cumulative for the P of X less than or equal to 19. It's not the one we're looking for, X greater or equal to 20, at least 20. So what we can do is, this is the complement for the at least 20 will pass. So this is the complement of what we want. So to find the complement, or to, based on the complement, to find what we're looking for is 1 minus. 1 stand for 100%. The probability we just calculated, which is 0.99, is about 99.97%. Okay, so for this particular one, when we actually looking for the binomials, we used X as 19, N as 46, and P as 67%. It's really slow. I cannot highlight things. Okay, I'm just going to put this in. Okay. Then if we're looking for C, that at least 30, I probably will do it here. For C, at least 30 will pass. For that kind of problems, we know that X for this case is going to be 30. It's still going to be cumulative. The probability we're looking for is at most 30. That means anything less than 30. So less than or equal to 30. So this is the lower cumulative portions. Then we don't need to find any middle steps. We can just directly using the binomial. And then X is 30, N is 46, and P is 0.67. Yes, it is cumulative, so 1. So we got 0.45, so it's about 45%. Okay. So what we just find for those binomials, those are the probability of something can happen. Then D, the last question for this example, D is calculating the mean and standard deviations. Because we're talking about discrete distribution, discrete data. So for the mean and standard deviation, we actually need to using a new formula to calculate it. The formulas are still going to require or still going to use the N, the P's, and one more thing is Q. So for the means, is actually find by using the N multiplied by the P. I can now have the equal sign, so N multiply the P. For the standard deviation, it's going to be the square root of the N multiplied by the P multiplied by the Q. Just to make everything simple, I'm just going to do 1 minus P. So here we actually defined a new symbol, Q, which is defined by using 1 minus P. So for those problems, if I'm going to find the mean, my sample size is still 46. My probability is 67%. So my mean is 30.82.